Well, hello and welcome to lesson 23-1 practice on, I love this, I don't know why, just the nerd in me, on page 321 in Springboard Geometry. So we're going to take a look at applying the law of sines, and I especially love question 8, or item 8, because it really keeps us in mind why and when we use the law of sines. And that's the thing we really need to focus on when learning all these different methods to find missing sides, missing angles. Why and when do we use these different methods? So let's dive in here. Item 7 says find each measure and round to the nearest tenth. I love that they actually give us that direction here. Sometimes we have to guess what they want us to round to, but they have established that we are going to round to the nearest tenth. So before I do anything on item A, do any real proportions using the law of sines, let's go and find the missing measure of angle y simply by taking 180 degrees and subtracting 75 and subtracting 44 to find the measure of angle y, which is 61 degrees. The next thing I'm going to do is go ahead and label the opposite sides of vertices, or the vertex, with its appropriate lowercase letter. Remember in the lesson we learned that opposite of vertex z, we'll use lowercase z, so z equals 10. Opposite of vertex x, we'll use lowercase x. And opposite of vertex y, we'll use lowercase y. So we are asked to round to the nearest tenth by finding each measure. In this case, we're finding yz, which we just labeled is lowercase x. Now, we are definitely going to use, and this is one thing we need to really be studying here, which ratios to use. We're definitely going to use vertex z and its opposite side because we have that complete ratio. We have the angle measure of z, and we have the length of its opposite side. So we're definitely going to use the sine of z over lowercase z. If you're wondering, how do I know which ratio to use, it's right there. We need to know an angle measure and its opposite side, and we're definitely going to use that in this proportion. Well, the next thing in fact, what we're really looking for is the distance from y to z, which is lowercase x. So it might be appropriate that we also use the sine of x over x. In fact, that is the length of the side we're looking for. So the sine of x over x. So now let's replace our variables with known values. So the sine of z, capital Z, or angle z, is 44 degrees. Lowercase z, that opposite side of vertex z, is 10, equal to the sine of x, which is the sine of 75 degrees. That's angle x. And its opposite side that we're looking for, which we established is x. So now we're going to do cross multiplication. So I will multiply 10 times the sine of 75. And some of you might be putting that in the calculator right now as I say it, but it's good to leave it just like this. We're going to put it in the calculator at the very end, just so we're not rounding as we go. So if you're tempted to put that in the calculator, you're not necessarily wrong right now, but rounding within the problem gets us further and further away from the exact answer at the end. So I'm just going to leave that as 10 times the sine of 75 equal to x times the sine of 44. I almost forgot the x there, 44 degrees. So this is x times the sine of 44 degrees. So I'm going to divide both sides by sine of 44 degrees so that x is by itself. So that, of course, will cancel that multiplication there. And I'll be left with x equal to 10 times the sine of 75 degrees over the sine of 44 degrees. And so we're going to use Desmos here. Or if you have a graphing calculator, feel free. 10 times the sine, and I'm just going to keep using those parentheses, especially those that are using a TI 83 or 84. You definitely want to use parentheses there. 10 times the sine of 75 divided by sine of 44. Let's just make sure I put that all in correctly. Looks good. And we found the length or the measure of x to be 13.9 because the 0 after the 9 tells that 9 to stay where it is. So the length from Y to Z is 13.9. Now I'm actually going to pause this and kind of move this work out of the way so I can have room to work item B. Okay, so for those watching, if you're wondering where the work went, I just moved it up here so we could have room to solve item B. So first things first, let's look at B and start to notice how it's already different than item A. Right off the bat, I noticed that on item B, I'm only given one angle measure. And we did explore in the check your understanding that did cause a problem. The main reason this caused a problem was we didn't know the opposite side of that angle measure, or we didn't know an angle measure and its opposite side, the way you look at that. So fortunately for us on item B, even though we only know one angle measure, we do have the opposite side of that angle measure. So that is going to be beneficial for us, and I'll show you why. So maybe you're thinking, okay, I have the angle of vertex D and I have the length of its opposite side. So let's definitely use the sine of D over its opposite side. Well, if the whole point is to find the length of DE, which we'll go ahead and label lowercase f, and I'll go ahead and label this lowercase d and this lowercase e. If the whole point is to find DE, which is lowercase f, we probably should use the sine of f over f. But this is where the real issue lies. We do know the measure of angle D, and we know its opposite side D, but we literally know nothing about angle F and its opposite side of F. So before we can actually use this proportion, we need to find another angle. And so let's use that same ratio, sine of D over D, and set it equal to another ratio, which we do actually have some information for. Opposite of vertex E, we do know the length of its opposite side, which I did labeled it lowercase e, which is 8. So even though we can't right off the bat find DE, which is lowercase f, we do have enough information to write another ratio because we have the opposite side of angle E. So we will, in fact, use the sine of D over D equal to the sine of E over E, because we will only have one variable missing in this proportion compared to the two we would have missing in this one. That is why I'm actually using this proportion. So let's replace it with known values. So the sine of 125 degrees, because angle D is 125. The size of its opposite side is 10. The sine of E, we don't know the measure of angle E. We're not even going to guess it, although there's temptation to. And its opposite side, which we labeled lowercase e, which is 8. So we're going to do some cross multiplication, and now we're actually going to solve for an angle measure. So if you recall back in our previous lessons, we used the inverse trig functions to find angle measures. So we're going to use that here. And notice the math tip. You may need to use the law of sines to find an angle measure before finding the measure of a side. In fact, they were kind of hinting at it for us. And this may require the use of an inverse trig function, which we learned back in lesson 22-4. So let's continue with our work just as normal. We're going to cross multiply here, and we'll get 10 times the sine of E equal to 8 times the sine of 125 degrees. I'm going to divide both sides by 10 because we're trying to get the measure of angle E. So we're going to divide both sides by 10. And I will have the sine of E equal to 8 times the sine of 125 degrees over 10. So if you recall, and they just gave us the tip here, now to solve for capital E, or the measure of that angle E, we're not going to divide by sine. That doesn't even make sense. We're going to take the inverse of this trig function. So we're going to do the sine inverse of this ratio that we have here, 8 times the sine of 125 degrees over 10, and that inverse is actually going to give us E. So the inverse of the sine function actually tells us the angle measure. So that's what we're looking for first, so that we can have a full ratio. And so once we know angle E, we can definitely find angle F. So I'm going to show you how to put this all in the calculator on Desmos. So in a new tab, we're going to find the inverse sine. And I'm going to go and use an extra set of parentheses, especially for those that are using a TI-83 or 84. You definitely want to insert another set of parentheses right here. And I'm going to type in 8 times the sine of 125. So 8 times the sine of 125. Close parentheses because I do want it to multiply there first and then divide by 10. And all the while, I want it to take 8 times the sine of 125, divide by 10, then take the inverse sine of that value. And I get 40.9. And so we'll keep it 40.9 for the sake of the degrees, even though we are rounding here. So we just found angle E to be 40.9 degrees. Now, in fact, we're not even looking, we really weren't designed to find the measure of angle E. We were simply finding the measure of angle E because we had its opposite side. And by finding angle E, now we can find angle F because all three of these angles have to add equal 180 degrees. And once we have angle F, we can actually go back and reuse this proportion that we wrote at the beginning. So angle E is 40.9 degrees. So now let's find angle F by taking 180, subtracting 125, and then subtracting 40.9, which tells us that angle F is 14.1 degrees. So now we have the measure of angle F, so we can go back to this original proportion that we wanted to use and find the opposite side of angle F, which we labeled lowercase f. So I'm actually going to do that work over here. So the sine of D, which we already know, angle D is 125 degrees. Seems my computer is lagging just a little bit. Hopefully that's not causing any issues viewing wise. So the sine of 125 degrees over its opposite side, which is 10, is equal to the sine of angle F, which we just found is 14.1 degrees, over its opposite side, which we already labeled lowercase f. So now we're going to do cross multiplication. We'll get f times the sine of 125 degrees equal to 10 times the sine of 14.1 degrees. And now this is f times the sine of 125, so we are going to divide both sides by the sine of 125 degrees. So this will cancel out or become the number 1, really. When you take a number, which sine of 125 is a number, when you take that number and divide it by itself, it becomes the number 1. So this is really 1f. I do want to keep establishing that, even though we use the term cancel so freely. That's really what's happening here. So f will equal 10 times the sine of 14.1 degrees over the sine of 125 degrees. So now we're going to use our handy-dandy calculators to evaluate this fraction. So I believe it was 10 times the sine of 14.1 degrees divided by the sine of 125. It said round to the nearest tenth. So that 7 in the hundredths place actually tells the 9 to round up to 10, which means that the 2 will actually round up to 3. So rounding to the nearest tenth, the length of DE is 3.0. So I really, really enjoy this question because the complexity of it. First of all, we're really figuring out when can we use the law of sines. It seemed back in the Check Your Understanding that we really had nothing to use or not enough information. But the law of sines really depends on an angle, the measure of the angle, and its opposite side. So the reason on item 6 in the Check Your Understanding we couldn't do it is we didn't have a complete ratio. Sure, we had an angle measure, we didn't have its opposite side. Sure, we have an opposite side, we don't have an angle measure. Again, sure, we have an opposite side, but we don't have an angle measure. So we did not have a complete ratio. On the other hand, on item B, we did have an angle measure and its opposite side. Unfortunately, we had to do a roundabout way to find another angle measure using a different proportion than the one we started with. So then we could go back to that original proportion and find the length that we were looking for all along. Which leads us to item 8. When can you use the law of sines to find the measure of an angle of a triangle? So let's go back to item B and express one more time how we use the law of sines to find the measure of an angle of a triangle. So we can use the law of sines to find the measure of an angle like we did here with angle E if we know another angle measure like D and the length of its opposite side. So we can find the measure of an angle of a triangle if we know an angle measure and its opposite side, as well as the opposite side of an unknown angle measure. So that was the trick here. That's what how B was a possibility for us besides 6 was. We had an angle measure, but we didn't know its opposite side. And we had its opposite side, but we didn't have its angle measure. So on the contrary, item B, we had its angle measure, its opposite side, and the angle we were looking for, or one angle that we found, technically we were looking for angle F, one angle that we found, we had its opposite side. Law of sines is all based around an angle measure and its opposite side. So it makes sense that once we have this information, finding other measures are possible. So that is it for lesson 23-1 practice. I definitely encourage, if item B kind of threw us through a loop, go back and watch it again, see why we decided not to use this proportion at the beginning, why we use this proportion, and again, how we use the inverse trig function to find an angle. But that is the end of lesson 23-1 practice. Hope that helps. Thank you for watching.